Okay, we have the endocrine system. The endocrine system has glands all over the body, like the pancreas here. The pancreas is an endocrine gland, makes hormones. Okay, here's the adrenal glands. Also makes some different hormones. Here is the thyroid gland. It makes all kind of hormones. Even in, see, here's the walls of the duodenum here. First part of the small intestine, it makes hormones. Okay? So, the endocrine system, I always talk about the pancreas. The pancreas, see this pancreatic duct here? It shoots enzymes into the duodenum. But 1% of the pancreas in the islets of Langerhans makes hormones like insulin and glucagon to regulate your glucose in your blood. So, the pancreas here, let's just say through diffusion, here would be a blood capillary, microscopic. So, the gland, the insulin, the pancreas makes insulin. It's a hormone. It secretes it into the blood capillaries, and in the blood plasma, the circulatory system brings the hormones all over the body. Okay? Now look, insulin, I always talk about insulin, and the pancreas makes insulin to regulate your glucose. So most cells, see this is the cell membrane of a cell. Say this is a muscle cell or a fat cell, whatever. Most cells have the protein receptors. See the purple things here? That's protein receptors. They have the receptors for insulin. So insulin diffuses out of the blood capillary through the simple squamous epithelial walls. So the insulin comes here to the protein receptors. Okay, see this pore here in the protein receptor? It opens up. Insulin opens up the protein receptor. Now, glucose from the blood capillaries, they diffuse through the hole right here, through the protein receptor, and go to the mitochondria to make energy. Otherwise, if the protein receptors are not responsive to insulin, which would be a type 2 diabetes, the glucose builds up in your capillaries and kills you. It destroys your capillaries. So that's what kills the people in diabetes. Type 1 diabetic, the pancreas doesn't make insulin at all, so you need insulin shots. Type 2 diabetic, these protein receptors don't respond to insulin, and you can cure that. Eat a better diet, low glycemic diet, and start exercising. So the important terms here, a gland like the pancreas makes a hormone like insulin. The insulin is put in the circulatory system. It goes to these target cells that have the protein receptors for the hormone like insulin. Okay. If it doesn't have the protein receptors, the hormone just goes on by. So that's our endocrine system, hormones. Okay, now we're going into our vision. Our vision, and you need to learn 6 more muscles. I mean, we've already learned 43 muscles, but now you got to learn, because these muscles deal with vision. They're hooked up. See the white of your eye, the sclera? So this would be superior rectus. It contracts and moves your eyeball up. Okay, the frontal eye field of your brain controls this, if you remember. Here's lateral rectus. There's inferior rectus. On the other side is the medial rectus. Here's the superior oblique. It works just the opposite, like a lever system. When it contracts, it moves the eyeball down. Okay, here's the inferior rectus and superior rectus. It's not really connected to the sclera. Okay, that's your 6 muscles that you need to know. You need to know the actions and what the muscles look like. Okay. You ask yourself, where does the tears come from to hydrate your eyes at? Or say you're crying at a funeral or something. Here is the lacrimal gland. The lacrimal gland puts tears on top of the cornea. The white area of the eye is the cornea. It needs to be hydrated. You don't want dry, do you? Okay, we have excess water. You don't want blurred vision, so we got to get rid of the excess water. So normally we need to hydrate that cornea. Here's the medial canthus area, a pooling area for the test. Medial canthus is a pooling area. It goes, we're trying to get rid of that water. We don't want blurred eyes. Superior and inferior lacrimal canalicus. Okay? The water comes down here, down to the nasolacrimal duct right here, and then it runs to your nose. So the ones people have heart trouble, medial canthus, a pooling area, and nasolacrimal duct, down to your nose, get rid of that excess water. And that's the lacrimal gland right there. Part of your vision. Okay. Here's our model of the eye. You need to know it. It's on the PowerPoints for you. Okay, we have 3 tunics of the eye, 3 layers. This white layer is the sclera, the white of your eye. Okay? And look, here's the superior rectus muscle right here. It moves the eyeball up, so it's connected to that sclera. Okay, the white is the eye, is your sclera. The dark area there, see where the blood vessels are, or the choroid coat. Starts with a CH, choroid. Okay? Then the inside layer, or tunic, is the retina. So, this is the retina right here. All of that is in the retina. Now look, say this is the macula lutea right here. Macula lutea on the retina. Let's take a look at that macula lutea. Okay, I have this on the practical here. Look, the macula lutea is on the retina. It has a high concentrations of cones. It's like a target, the book says. High concentrations of cones, macula lutea. Cones help you see sharpness and color. Okay, in the middle is fovea centralis. Fovea centralis is a super high concentration of cones, no rods. Rods help you see in dim light. Okay, they're hooked up to the bipolar neurons of your eye. Okay, so here is the retina of your eye. The round thing is the macula lutea, the target, and in the middle is fovea centralis. A super high concentration of cones, no rods. People with macular degeneration, this area gets destroyed and they go blind. Okay, back to the model here. So that's the 3 layers of the eyeball there. Let's put her back together here. Okay, look, the sclera in the posterior comes around and finds the cornea. The cornea is marked in green here, 26A, that's the cornea. Okay, the second layer we said is a choroid coat here, choroid coat, and it comes around and forms the iris, the color of your eyes. Okay? Here is the lens right here. The lens, it focuses eyes to the macula lutea. Focuses that light to the macula lutea, the lens. When this changes diameter, older people can't see up close anymore. Okay, look, there's 2 fluids in your eye. This area right here is aqueous humor. See, the cornea is like a cup-shaped structure, and there's aqueous humor here. The liquid is called aqueous humor. And look, here's the posterior cavity that makes up most of the eyeball. And inside here is vitreous humor. So, aqueous humor behind the cornea, right here, behind the cornea. And the vitreous humor in the posterior cavity. Okay, and the pupil's missing here. When light hits that pupil, it shrinks up. It either dilates or restricts. When the pupil's too much light, it restricts. Not enough light, it dilates. Okay, in the back here this is the optic nerve, and it runs to the occipital lobe of your cerebral cortex to see vision. What are you seeing? But it forms a blind spot. They call it the optic disc right here. The optic disc is right here, called a blind spot. Right here. Okay, and the lens, it's held in place by suspensory ligaments right here. And that's the ciliary body. Okay, ciliary body. The lens is held in place by suspensory ligaments. Okay, now we go into another sense of vision. Sense of auditory. Auditory, So here's the ear right here. You got to call it the auricle. It's made out of elastic cartilage, remember? It's got skin on top, but most of the ear is made out of elastic cartilage. Okay, sound waves are measured in decibels. The sound waves hits the auricle. It comes, the ear canal, you got to call it external auditory meatus. And it hits the tympanic membrane right here. It starts vibration. See that tympanic membrane? And it starts vibrating, and it vibrates. There's three ear ossicles in here. The malleus is hooked up to the tympanic membrane. Malleus, incus, and stapes, they call them, the ear ossicles. Okay? Look, here's the cochlea. It looks like a snail, doesn't it? And look, the stapes right here, see this? That's the oval window right there. Malleus, incus, stapes connects to the cochlea, forming this oval window. It's not really a window. So sound waves go into the cochlea. Inside here is the organa corti, where the hair cells are. There's like 15 to 20,000 hair cells in here on the organa corti. They call it the spiral organ. It's one organ. You got to call it the organa corti. And it sends vibrations to the temporal lobe of the cerebral cortex in here. Okay, semicircular canals here, they have to do with equilibrium and balance. They don't have to do with hearing. Okay, here's the tympanic cavity here, and look, see the cochlea? You don't want any echoes in there, so you have the round window that sends out vibrations to the tympanic cavity here. You don't want any echoing, so excess sound vibrations come out here. And here is the eustachian tube. It runs down to the nasopharynx of us, and it equalizes pressure between the internal and external tympanic membrane here. Okay, that's pretty much our basic auditory. You got to call it auditory. Okay. Now we go into the sense of gustatory. Remember the parietal lobe, there's two areas in the parietal lobe of the cerebral cortex that taste. Taste is called gustatory. Okay, here's the top of our tongue. We got about 10,000 taste buds on the top of our tongue. And the taste buds are on the sides of the papillae. See, our tongue is rough because of the papillae, little bumps that stick up. And there's like 10,000 taste buds on the sides of the papillae. Okay? There's three types of papillae. The filiform, the fungiform, and the circumvallate. See this little ring right here, the circumvallate? So that's filiform, fungiform, kind of over in this area, and circumvallate, the book says. Here's where we taste salty and sweet, the tip of the tongue. Here's sour, and the circumvallate, they taste bitter. Okay? So, look, here's a microscopic view of a taste bud. Here, the whole thing is the papillae, the little bumps, okay? The little bumps on the top of your tongue. We got about microscopic view. See the round thing? That is the taste bud. We got about 10,000 of them. Say you're eating ice cream. See, bluebell ice cream. The molecule hits these microvilli. See that microvilli? They're really dendrites. It sets an electrical impulse. Inside here, you got supporting cells and gustatory cells. Okay, it sets an electrical impulse all the way to the parietal lobe of the cerebral cortex, and you remember that is taste. Okay, so just remember, these are microvilli. That's air at the top of your tongue. The round thing is the taste bud. We've got 10,000 of them. Inside, there's two types of cells in there, gustatory cells and supporting cells. Electrical impulse goes this way to the parietal lobe. And you remember what bluebell ice cream looks like and tastes like. Okay, look, olfactory is the sense of smell. Okay, look, we breathe in the nasal cavity right here. And on top of the nasal cavity, we got two olfactory organs. This whole thing is an olfactory organ. Okay, let's take a look. Here's a sagittal cut. See, we breathe it in, say, like coffee fumes. Go through our nasals. And here's the nasal cavity. See these ethmoid bone? The conchas of the ethmoid bone here, and it turbulates the air. Say if there's fumes in there like coffee fumes, you got 2 olfactory organs right up here on top of our nasal cavity. Okay, here's what these olfactory organs look like. Okay, fumes come in, start everything with olfactory. See the gray area? They hit the mucus. It's olfactory mucus. Olfactory gland makes the mucus right here. Okay? It's number 7. Olfactory gland makes the mucus. Okay, these olfactory cilia, little pink things, they're really dendrites. So electrical impulse goes this way up. Don't call these bipolar neurons. They're olfactory receptor cells or neurons. Okay, so and these, the white ones, are the supporting cells. So electrical impulse goes the olfactory receptor cells up the ethmoid bone. There's the olfactory foramens of the ethmoid bone. You got to call them olfactory foramen. Okay. Then the axons hook up to the dendrites of the olfactory bulb. Number 1 here is the olfactory bulb. Okay. Then we send electrical impulse to the frontal lobe and the temporal lobe, and we remember what coffee smells like, and that is coffee. Okay, just remember, we got 2 olfactory organs. This is 1 organ. You got olfactory gland, makes the mucus. And we got olfactory bulbs, where the axon dendrite connections occur. Then it sends it off the electrical impulse to the frontal lobe and temporal lobe, where we interpret our olfactory, which is the sense of smell.